Today we're going to discuss instantaneous rate of change and tangent lines. Now, a tangent line can be defined as the rate at which the value of the function y equals f of x is changing with respect to x at any particular value x equals a to be the slope of the tangent by the curve y equals f of x at x equals a. Now the problem we face is, how do we define the tangent line at any point P on this curve and find its slope from the formula y equals f of x? Now, the problem is that we have one point, and while our usual definition of slope requires two. But in the year 1629, Fermat had created a new way in order to find the slope of a tangent line with only one point. First, we find the slope through point P and Q on the curve, which happens to be the slope of the secant. Next, we find the limiting value of the secant slope if it exists as Q approaches P along the curve. If you don't understand what that means, you'll see in further questions as to how and what that means. Finally, we define the slope to be this number and define the tangent at P to be the line through P that consists of this slope. Now, if you don't understand what this means, you'll understand right now as I continue on with the first question. The first question asks for us to find the slope of the parabola y equals x squared at the point 2, 4 and write the equation for the tangent to the parabola at this point. Now here's the equation, here's the graph for the y equals x squared graph, and we have point P, which is 2, 4, which is provided in the question, and then we created this new value, 2 plus h, because we know that delta x will be h, and we needed to create an arbitrary value in order to figure out point Q. And using delta x equals h, we were able to plug that back into the equation x squared to find out what y is equal to for point Q. So point Q is equal to 2 plus h, comma 2 plus h squared. And then we needed to figure out delta y. Delta y is equal to 2 plus h squared minus 4, because the y value for point Q is 2 plus h squared. And we subtracted 4 because we have to subtract this portion down here. Thus we have delta y equals 2 plus h squared minus 4, and the secant slope, which is the slope between these two points, is going to be delta y over delta x, which happens to be 2 plus h squared minus 4 over h. We have to do exactly what Fermat had told us. He told us to take we have to find the limit as Q approaches P of the secant slope. Now, what we have is secant slope is equal to delta y over delta x, which is equal to 2 plus h squared minus 4 all over h, which is equal to h squared plus 4h plus 4 minus 4 over plus 4 minus 4 all over h, which is equal to h squared plus 4h all over h, which is, and then the h is cancelled out, so you're left with h plus 4. Thus, the limit of the secant slope as Q approaches P along the curve will be limit as Q approaches P of the secant slope, which is equal to limit as h approaches 0 of h plus 4, which will equal to 4. So then, that, according to Fermat, what we just did provides us with the slope of the parabola at P. So we got slope of parabola equals 4. Now we have to find the tangent line at this point. So the tangent line at this point will have the slope equals 4. Let's use a different color. And we have the point P, which is equal to 2, 4. So using the y-intercept form, or point slope form, we have y minus 4 equals 4 times x minus 2, y minus 4 equals 4x minus 8, y equals 4x minus 4. And thus we have the equation of the tangent line at point P, which is of the parabola y equals x squared at 2, 4. Now moving on to slope of a curve at a point. We're going to use purple now. So what we determined was that the slope of the curve y equals f of x, slope of a curve y equals f of x at point a comma f of a is the number m equals limit as h approaches 0 of f of a plus h minus f of a all over h. And that is provided that the limit exists. Moving on to the normal of a curve. Now what is the normal line? A normal curve to a curve at a point is a line perpendicular to the tangent at the same point. So given this question, we have write an equation for the normal line to the curve f of x equals 4 minus x squared at x equals 1. Now first we have to find the slope of the tangent. What do? We have m equals f of a plus h minus f of a all over h. So in this case it would be f of 1 plus h minus f of 1 all over h, and we have to take the limit of that as h approaches 0, limit as h approaches 0. So then we continue, limit as h approaches 0 of 4 minus 1 plus h squared, 1 plus h squared minus 3 all over h is equal to limit as h approaches 0 of 4 minus 1 minus 2h minus h squared minus 3 all over h, which equals limit as h approaches 0 of negative h times 2 plus h all over h, which comes out to equal to negative 2, because the h's will cancel out over here, so you're left with negative 2 minus h. Plugging in 0 for h, you get negative 2. Thus, the normal of that will be, normal is the equal to negative reciprocal and thus we have that slope of normal will equal 1/2, because that is the negative reciprocal of negative 2. Now it asks to find an equation for this. The equation, we're going to move to a different color. The equation for this will be, knowing that the slope is going to be equal to 1/2. The point is equal to 1, 3, which you can find after plugging in x equals 1 back into the equation. So using point slope form, we have y minus 3 equals 1/2 times x minus 1. Y equals 1/2 x minus 1/2 plus 3. And y equals 1/2 x plus 5/2. So thus, that is the equation of the normal curve of the equation 4 minus x squared at the point x equals 1. Finally, we have instantaneous rate of change. Now, instantaneous, we're going to use a different color once again. Actually, no, that's the color of the title. We're going to use pink. Using this, we have that instantaneous speed at any time t is the instantaneous rate of change of position with respect to time. Instantaneous rate of change. So thus we have limit as h approaching 0 of f of t plus h minus f of t all over h as the instantaneous rate of change. So now we have an example in which it asks to find the speed of a falling rock whose position function is y equals 16t squared. Thus, using the equation, and we're trying to find it at t equals 1 second. At t equals 1 second. So, thus we have f of 1 plus h minus f of 1 all over h equals 16 times 1 plus h squared minus 16 times 1 squared all over h, which is equal to 16 h squared plus 2h all over h, which is thus equal to 16 times h plus 2, because the h's will cancel out, which provides you with that as the final equation. And considering we have to find it at t equals 1, we have to take the limit as h approaches 0 of 16 times h plus 2. Thus we have 32 feet per second as the instantaneous speed at t equals 1 second. And that concludes all that we have for instantaneous rate of change and the tangent line. Thank you.